So, this is a very small introduction to how you can make the world a better place by building security into your Android apps. This is roughly what I've been talking about. A bit of intros, and then I'm going to give you some actual tangible secure coding techniques in Android. And then I'll give you a bit of a hint on where you can go from there if you're interested in learning more. Okay? So, yeah, my name is Nina. I'm a principal information security consultant at Westpac. So I review source code all day long for the bank and the many banks the bank owns to try and find vulnerabilities in source code before it goes live. So I've been a developer for a long time. As Georgia said, I wrote my first Android app in 2010. Yeah, that's me. So, as I was saying, I was a developer. Sorry. Bloody transitions. Yes, and one day I got sick of all these headlines, the data breach here and the data breach there, and it's just wrong. It shouldn't have to be like that. We are the developers who build applications who get breached and who get hacked into. Why does it have to be like this? Who here knows or heard anything about stage fright? Anyone? A few people, yeah. Big problem where they found a major vulnerability in one of the native libraries and on the Android platform. And there's a lot of negative security press. So, do you think that your Android app is secure against an attack? Hands up. Great! Send me your email address. We need to hire you. That's awesome. Yeah. No, it's good. Look, I feel for you. I've coded so many applications in my life which I'm sure are completely insecure because it's not what you think about, is that you think about getting that feature done and getting that release and that sprint or whatever it is you're working towards. That security can easily get left behind. But the truth is, it's very easy to build security in. It doesn't take any longer. So why not, as I said, make the world a better place and actually just do it. So there was a recent investigation by some academics who looked into all the publicly known 660-odd vulnerabilities. See, on the internet, there's this database with this publicly known vulnerabilities in all the sorts of different software platforms. So they looked into where in the platform, where in the Android platform do they actually sit? And as you can see them, a depressingly large amount actually sit in the kernel itself. You can interpret this how you want to. I try to be positive about this and think, it's kind of good because we can't really do anything about the problems that are in the kernel or the native libraries, right? But we can do something about security in our apps. And the security problems in the apps actually only account for about 15%. So I'm sure the Android development team will pick up their game now that there's so much publicity about their security problems. So stage fright, for those of you who are familiar, was in the media library of the native library of the Android platform. But there's good news, because the same academics who looked into this classified all the vulnerabilities into a few different types. And they figured out that there's basically a couple of different types of vulnerabilities. One big one is memory, dealing with memory, so memory buffers, allocating memory, and then buffer overruns, and so forth. And also, a big problem is, how we validate and treat data that comes into our application. So the good news here is that we can fix all these things with secure coding practices. It's easy, okay? It's a good thing. So before I delve into the technical details of what we all should be doing, if we're not already doing it, which I'm sure you all are, but just in case to double check, I'd like to understand the secure coding mindset. Don't trust anything, okay? You have a nice little form on your app where, you said, I'd like the user to enter their first name. And you expect the user to enter the first name, and what if they don't? What if they enter a really malicious code that will do something horrible to your application, like steal your data or break the phone? Who knows, right? So just don't trust it. Validate, validate, okay? Don't trust other components. You're calling some other component, some API, some third-party library. Don't trust it. Use it, but don't trust it. Just validate wherever's coming in, okay? So I'll tell you a bit of a story of when this was not done correctly. So Samsung makes devices that have Android on them, right? So up until 2015, all devices that had Android 5 were actually vulnerable to remote code execution, which is security speak for an attacker can do whatever they want with your phone, including stealing data and destroying it, etc. Right? So, and why was this? Well, it was because the Samsung OEM customization had a very nice little feature, which monitored the download directory on the SD card, and if a file turned up that was called something cred, something .zip, it would unzip this and put the content on the phone. Now, the problem with that is, of course, that hackers figured this out. So they wrote some malicious code, put it in a zip file and call it cred.zip, and then tricked users into downloading this by, for example, sending them an email saying, hey, look, cute kittens here, click here. And people do. There's very sophisticated social engineering attacks where people are really tricked into doing this. So, and then once they've done that, the attackers figured out how to then put those files into the Dalvik cache, and it's very technically complicated. You can look it up yourselves. But trust me, it was a bad thing. So what was the problem there? Well, it was that they just blindly trusted the fact that if the file is called this, it must be our file, and therefore it's all hunky-dory. Okay, so don't trust. So let's look into these vulnerabilities, the most common ones that these researchers identified. So securing buffer boundaries. Good news, again, it's simple. Use Java. Java is your friend. There's no pointers in Java. Stay away from native code. If you know what you're doing, great. But please, if you use native code, you've got to deal with pointers and buffers and memory allocation, which is fine if you're an expert and you know what you're doing. But apparently, looking at the vulnerabilities we see in the Android platform, this knowledge doesn't seem to be all that widespread. So, but just stick to Java. Very simple, right? Storage. So you may need to store something on the device. Okay, if the phone is rooted or jailbroken, all of Android's very nice security features are all gone, all right? So this is assuming the phone is not jailbroken or rooted, okay? So you can safely store your data in the /data, and then the name of your application, right? That's good. Preferably encrypted. That's good too. If you need to store passwords, you can do that in the key store. That's good. Have a little think about what you're putting in memory, because memory can also be inspected by other malicious apps who's on the same phone. And when the user logs off or stop using the application, it would be good if you could clear those. If you have anything sensitive in memory, if you just clear that, for example, initialize those variables with some junk value to override it. Don't ever store anything on the SD card. All applications can access the SD card. Be aware, dangerous, okay? For those of you who use SQLite, that's fine. You can do that. However, there is a very serious vulnerability called SQL injection, which you may potentially introduce. And this is a very short talk, so I won't go through the details of that. But just bear in mind that please use prepared statements. Don't concatenate strings, because then you open up yourself to SQL injection. Okay? So, coming back to securing input, validate, always everything, okay? Don't ever trust anything. Start already at the UI. If you know that the value you're expecting is only going to have numbers in it, that's great. Just, declare it as an input type number to start with. Also, this might sound contradictory, but just because you do that in the UI doesn't actually mean, if you're passing that value onto the back end somewhere else, doesn't actually mean that it's not manipulated and changed. So you can't trust the UI as a means of validation, but it just narrows the the scope and the risk for malicious input. So check again at the back end, please. Whitelist. Have a think about the values you're expecting. If you're expecting something that only is supposed to have letters and numbers, then you can use a regular expression to validate it. You don't expect, $sign and dots and slashes, which is very typical in malicious code. Intents. Please use explicit intents. That's when you declare exactly what class you want to use, and not just say, yeah, I would like to do something like that, because then you open up yourself to a whole bunch of problems. The exported attribute in the manifest is quite. It's a bit. If you don't use it, then you may inadvertently export your activities anyway if you use an intent filter. So if you deliberately export it, at least you know what's exported. It's something to keep in mind. There's also the permission and the protection level attributes. Please use them, read up on them and use them. They're really good. And please don't ever trust other apps' intents. Assume that they're malicious, all right? You can use them, but just assume that they're malicious, and you need to validate and reject anything malicious, okay? So you've written your wonderful app, and it's secure and lovely, and you're about to ship it. Please obfuscate your code. If you don't, I can just download your app, and I can grab the APK, and I can reverse engineer it, and I can find all the little problems you have in your code, that hard-coded password there or that vulnerability there. ProGuard is a good way to obfuscate. Does anyone know of a better tool to use for obfuscation? Yes? Ah, there you go. Yeah. Righto. Oh, okay. Wow. Oh, there you go. Great. Okay, so look up what the best obfuscation technique is. Very important. Yeah. Great, thank you. Something you can also do is use tools that know more, hopefully, or maybe, about security than you do. So you can use a technique called static analysis, which basically reads in your source code and figures out if there are any potential security problems with it. A couple of these are the Drozer is specific to Android. I was talking to the penetration testers in my team, and they highly recommend this. I haven't used it myself, unfortunately. And then there's the Mobile Security Framework, which is also it's for Android and Apple. In a bigger, sort of more complex corporate environment, like at the bank where I work, we use 45, which is a HP product. Checkmarks is another one of those, but they're like more generic for all sorts of source code for different languages. So this is an example of the sort of report you get out of the Mobile Security Framework. It's hard to see, but basically Ingo's APK outcomes report, and the couple of things that it says here is, oh, you forgot to turn off debug, and you have an intent filter here on an activity, and that means it's exported, and just to make you aware of little things that you may have forgotten or not configured quite correctly. Drozer, is a command line. It's very similar to Metasploit, for those who are familiar with that, which is a security penetration testing tool, where you can automate attacks. So be aware, there's evil tools out there, but it's good to try and attack your own app before you release it, right? So I also highly recommend that you learn more about secure coding, and one way to do that is to download a deliberately insecure Android app and then tear it apart. So this one, for example, is GoatDroid. It comes with the source code, the server, so you can spin it up and play with it and hack it, and also with a tutorial that explains all the potential security problems with it. And I'm happy to share this slide, so I have lots of other goodies. But so I highly encourage you to read up more on security for Android developers. In particular, you can start off with the security articles that Google have on Android. Always top 10 from mobile is a great resource as well. Mobile security framework, as I mentioned. So yeah, that was me. Questions?
We have time for a couple of questions. Again, Maria.
With obfuscating your code, how do you deal with getting stack traces out when you're looking at your reporting without them being obfuscated?
So yeah, so you obfuscate the code, right?
My code,
yeah,
all my stack traces are going to be obfuscated and useless.
Yeah.
Is there
but you shouldn't have, like, the obfuscating the code is like the final, you do that for the final package that you're actually releasing.
So if I'm logging errors, for example, that I want to inspect.
Why would you be logging errors in production code through stack traces? That's called information leakage. Don't do that.
To find out where, like, for example, one thing that it's very useful for is if your backend gives you bad data and it causes a null pointer, you can find out where it happens. But don't do that. Yeah. Yeah.
Doesn't also Android have the feature, if your app crashes, you can, like, send a report? Yeah. Not so good, no?
They don't go through.
I know. Yeah. I see. Yeah, the fragmentation is it's tricky, isn't it? Yeah. Oh, yeah, that's true. Yeah, there's always trade-offs. Bloody security always gets in your way. It's, anyway. Any other questions? Yeah. Sorry, which what? The what? Oh, native code, yeah.
So you say that you don't use JNI? All the libraries. And it's really hard.
I think your colleague behind you is disagreeing with you. Do you want to answer that one?
No, I mean, tools like APKS do work. Well, I think they need some context.
Yeah.
Video games might be more.
Yeah. No, it's not always bad. It's just you do open up yourself to potential buffer overruns, etc. But obviously there is entire industries which are built on C and C++ code. But yeah, you introduce potential memory problems. You just need to be aware of that and just know what you're doing, really. Yeah. No.
No, not really. There's that, for example, like breaks harder.
Maybe you can come next week and give a talk on, decompiling and obfuscation. I'd be really interested in that, because I don't know it's nearly as much detail as you do. Though.
We do have a slot open.
Yeah.
Next week.
See? You just have a volunteer. Righto. Well, thanks, everyone.
Well, thank you very much.